In this video, I'm going to talk about pass by value and pass by reference. Take a look at this program. We have a main method, and inside the main method we have initialized a variable x, and we are sending that as a parameter to a method which is in another class. Here is how it works. We'll have a stack memory in that a block will be allocated to main. In that we'll have the value x, which is 10. When we call a method from inside the main, we're going to stack up another block for that method, and note that we're sending this parameter x. If we are talking about pass by reference, then we're actually sending this value to this block. In Java, it is not supported. In Java, there is nothing called pass by reference. We only have pass by value, wherein we'll send a copy of that variable. So when we do this, we're actually making a clone or a copy of this field, and we're sending it to this method. So we'll have another variable. The scope of this variable is within this method, and once this method exits, then this block will get freed. If we are using pass by reference, then the value of x would be 20. That's because we are updating the value here. But since Java is pass by value, the value of x would still remain as 10, not 20. Now we understood what is pass by value and pass by reference. Let's take a look at our code. I have jotted down 3 different scenarios. In our scenario 1, we have a variable x, and we're sending that as a parameter. The initial value of x is 10, and after we send that value or the variable to this method example 1, we're updating the value of x to 100. The line next to it is we're just printing the value of x. Since Java is pass by value, we're not actually sending this x. We're actually making a clone or a copy, and then we're sending the copy to this method. So in essence, nothing will get updated, at least in main method. The value 100 is applicable all the operations that you do in this example 1 method, and once we come out of it, the value would still retain to 10. So the output of this statement would be 10. The confusion arises, however, when we send an object. Objects are references, and this might sound a little confusing because when you're sending a reference, that might sound as pass by reference, which is wrong. We're still sending the reference type as a value. We're not actually sending this math object, we're actually sending a copy of the reference object. A copy of the reference. I mean, this math object will only constitute the address wherever this object is residing in the heap memory. And in example 2 method, we're essentially a copy of that address. And when we do so, this new variable in here will have that address assigned. And the scope of this variable is actually within the block of this. I think this can be better explained in the whiteboard. Let me take you there. Again, let's assume we have a stack memory and heap memory. Since we have created 2 new objects, we'll have an object of examples, we'll have another object for maths with some addresses. In our main method stack block, we'll have these reference variables obj and maths obj. We're good so far. Now in here we're calling a method, and whenever we call a method, we'll have a new block created in the stack for that method. For example 2. And when we're sending this object, we're not actually sending this reference type. We're actually sending a copy of it. So a copy of this is made and is made available here as well. Maths object. But take a note of this. both these two reference variables are actually pointing to the same object. Hence, this statement in here, object.x, if we make it to 100, the change will reflect in here as well. When we do system.out.println mathsObject.addition, then it's going to find the sum of 100 and 5, because the value x, which was 5, is now updated to 100. Now let's go back to our code. We have a third scenario here. I'm essentially doing the same thing what we're doing here, but if you go inside that method, example 3, I'm creating a new maths object and assigning that object to this new reference variable, and then I'm trying to update the value of x in here. I have jotted the same code in our whiteboard as well, and let me explain you over there. Once again, we'll have a stack memory and heap memory with two objects. One is of examples, one is of maths. When the interpreter comes across with this statement, we'll have another block for that method, example 3. And by the way, main block will have object and maths object. Since we send this object as a parameter to this method, we're going to have another copy of this reference variable. Great. So we've reached till this point. Now, when this statement is interpreted, we'll create a new object altogether. This is a third object, and the reference name that we used is new object here, and we assigned this reference to obj. So obj was actually pointing to this object earlier, but with this line, now it's pointing to whatever this reference variable is pointing to. Now this is pointing to this object, hence even this would start pointing to this object. This is no longer pointed to actual object. So whatever updates I do with object.x equals to 20 or object.y equals 30, it will be updated in this particular object, but not the original one. Based on your understanding, okay, let's go back to our code. Now try to look at the code and try to guess the output of this program. The output of this would be 10. The output of this would be 105. And the output of this would still be 105. There won't be any difference. Let's run the program. There you go.